Alright, so we're solving problem 38 from chapter 7, and the problem says, two blocks with different masses are attached to either end of a light rope that passes over a light frictionless pulley suspended from the ceiling. The masses are released from rest, and the more massive one starts to descend. After this block is descended 1.2 meters, its speed is 3 meters per second. If the total mass of the two blocks is 22 kilograms, what is the mass of each block? So, we have, this is going to be a ceiling with the pulley that has two blocks attached, and they're not the same weight, and initially they're held at rest and then they're released. We know that the mass of both of the blocks, the total mass, is equal to 22.0 kilograms. We also know that after the blocks have been released, they have traveled a distance, a height of 1.20 meters, and have a velocity of 3.00 meters per second. And it wants us to find the mass of each block. So we've got block A and block B. So, in order to do this, there's some things that we need to understand. So we know that the initial kinetic energy plus the initial potential energy, because energy has to be conserved, is going to be equal to the second kinetic energy plus the second potential energy. Because the blocks are initially held at rest, this side goes to 0. So then we have 0 is equal to the second kinetic energy plus the second potential energy. So we know that the second kinetic energy is going to be equal to it's going to be equal to 1/2 times the mass of block A times its velocity squared minus the mass of block, or plus the mass of block B times its velocity squared. Because they're connected by a pulley, they're going to have the same velocity. So we can take that out. They have a velocity of 3 meters per second squared times mass A plus mass B for K2, or second kinetic energy. We also know that the potential energy is going to be equal to mass A times gravity times the height of A mass B mass B times gravity times its height minus mass of A times gravity times its height. It then has, they both have, so their change in height would be the same, and so like up here we can pull those out. So gravity times the height times mass B minus mass A is our second potential energy. We can then take these equations and substitute them back up into this equation. So we get that 0 is equal to 1/2 times 3 squared times massive A plus massive B plus gravity times the height times massive B minus the massive A. So, well, mass A plus mass B is going to be equal to our total mass, and so that is going to be 22 kilograms. We know the change in height, and we use the velocity over here, so we're just solving for these. So massive B minus massive A is going to be equal to 1/2 times 3 squared times 22 divided by gravity times the height, which gravity is going to be 9.8 times 1.2, which when you do the math, that then comes out to 99 over 11.76, which is also equal to 8.42. So then we have massive B minus massive A is going to be equal to 8.42. Well, we know that massive B is going to be equal to 22 kilograms minus the massive A, so we can rewrite that as 22 minus massive A for B minus the massive A equal to 4.42. We can then do the math to isolate for massive A. So massive A, so 2 times the massive A is going to be equal to 8.42 plus 22. So massive A is going to be equal to 8.42 plus 22 divided by 2. And if you think like, but wait, over here this term is minused, and we would subtract it to the other side, and then we would also divide both sides by -1 in order to get rid of this minus side. And so that's how it becomes plus A2. And then we would actually add back that over. And so you get that the mass of block A is going to be equal to 15.21 kilograms. We can then take that and subtract that from the total mass, because 22 minus the mass of A is equal to the mass of block B, and we get that mass of block B is going to be equal to 22.0 minus 15.21, which gives us a mass of 6.79 kilograms for block B. So block A is heavier and has a mass of 15.21 kilograms, and block B is the lighter one with a mass of 6.79 kilograms.